Well, hello, ladies and gentlemen. Are you coming? Am I coming through, basically? Can you hear me?
Yes.
All right, we're going to finish chapter 5 today, 5.7. And then I will make available the chapter 5 quiz. And today is Wednesday, see 18, 9, 20. And I'll probably make the chapter 5 quiz maybe due by midnight Saturday night, the 20th. Okay, but I'll make that quiz available. But we're going to close the door on chapter 5 by showing ourselves how to divide polynomials. And we're going to look at long polynomial division, which is a technique that actually is used from time to time in higher level math. Okay, so section 5.7. All right. Okay. All right, so dividing polynomials, section 5.7. First, we're going to show you how to divide a polynomial by a monomial, and then we'll show you how to divide by a polynomial. In order to be successful in dividing polynomials, we need to remember in general how we divide like bases. Do we remember or recall what we do with the exponents when we divide like bases?
Subtract.
All right, we subtract the exponents. That is obviously a property we're going to have to import into this section here. All right, in general, if I have a multi-term, what's that? Pardon? I'm just saying when we divide like bases, we subtract exponents, correct? Right? That was a property of exponents we learned in the past. Now, if I got a multi-term polynomial in the numerator divided by a monomial, ladies and gentlemen, it's legal to break this up into separate fractions. That's a property that we've known ever since basic mathematics, in the sense that when we got a common denominator, we were able then to go from the right to the left. Well, today we can go from the left back to the right, okay, in dividing by a monomial. All right, so let's see if we can divide a polynomial by a monomial. Section 5.7. Let's take 6x plus 8y. We try to divide it by 2. All right, how do we accomplish this? Well, I can split this up into 2 fractions. I can place every term in the numerator over this monomial denominator. And now we just have to reduce each of these individually. 6x divided by 2 reduces down to 3x. 8y divided by 2 reduces down to 4y. We have just divided as binomial by that monomial. Any questions how we did that problem there? Okay. Let's take 12xy squared minus 18x. And let's see if we can divide this by negative 6x. To divide a polynomial by a monomial, all we have to do is place each term of the polynomial over the monomial. And then we just have to reduce each of these here. So How does this first one reduce? 12 over -6. What does that reduce down to?
-2.
-2. What happens to the x's here? The x's just
Cancel out.
reduce out to ones, and we're left with -2y squared. What's a -18 divided by -6?
Negative +3.
+3. What happens to the x's? The x's what? Reduce out. And we're left with this for our quotient here. -2y squared plus 3 is a quotient of having divided this binomial by this monomial -6x. That makes sense there? Are we divided by that monomial? Okay. All right, let's try another one here. All right, to divide this binomial by this monomial, again, we can split this up, placing each term of the polynomial over the monomial. What's this going to reduce down to now? Well, we have a positive over negative. We know this is going to be a negative. What's a squared divided by a? That'll be the a to the what? 2 minus 1 power. A to the 2 minus 1 power is a. What happens to the b squareds here? They reduce down to 1. We're left with negative a. What's a negative divided by a negative? Just a positive. These a's reduce down to 1s. These b squareds reduce out to 1s. So we're left with negative a plus 1. Any questions about that problem there? Pretty simple so far. Dividing a polynomial by a monomial.
Yeah.
Let's try this one here. Let's try 6x squared a plus 12x squared b minus 6x squared c. We're going to divide this trinomial by this monomial here. All right, to do this, we're going to place each term of our polynomial over the monomial. So I'll place this over 36x squared plus place the 12x squared b over the 36x squared plus place the negative 6x squared c over the 36x squared. All right, can I reduce this? 6 over 36 reduces down to 1/6. X squareds reduce out to 1s, and we're left with an a. 1/6 a. $12 over 36, can we reduce that?
Yeah.
What does that reduce down to? 12 over 36. 1 over 3, 1/3. X squareds reduce out to 1s, and we're left with b. 1/3 b. Finally, -6 divided by +3 is a -2. X squareds reduce out to 1s, and we're left with c. That would be it. That would be your answer. Any questions how we're dividing a polynomial by a monomial? Pretty straightforward. Pretty straightforward so far. Okay.
I'm a little confused. How did the last problem go to a 2?
Me too.
It should not be a 2. That should be -1 over what? 6, shouldn't it?
6, yeah, okay.
Oh, boy. Wow. So unfortunately, my Monday continues. Should be -160. Mhm.
Thank you.
So 160. All right. So in general, to divide a polynomial by a monomial, ladies and gentlemen, we place each term of the polynomial over the monomial, and then we reduce each of the fractions. Each of the fractions get reduced. All right. Tell you what, maybe you guys can try one on your own now, huh? So I'm going to give you a polynomial. I want you to divide it by this monomial, and you can see how that goes. Okay. So we'll call this classwork number 1. Today is the 17th day of November already. Okay. So divide. Problem number 1. All right, see if we can do those problems here. Dividing a polynomial by a monomial. Okay, so dividing a polynomial by a monomial, we can split this up. And place this each term over the denominator. And then it comes down to, can we reduce a monomial over a monomial? All right, 5 over 20 reduces down to 1/4. These a squareds reduce out to 1s. Now, this x in the numerator, when you divide like bases, you subtract exponents. So this is going to be like x to the 1 minus 2 power. X to the 1 subtract 2 power. Negative 10 divided by positive 20 reduces down to negative 1/2. The a is a to the first power divided by a to the second power is going to be a to the 1 minus 2 power. These x squareds reduce out to 1s. 15 over 20 reduces down to 3/4. A squareds reduce out to 1s, and the x squareds reduce out to 1s. Now, we don't like to leave any negative exponents appearing in any denominator. So this is x to the negative 1 power. Because it's x raised to the negative 1 power, we got to flip x down into the denominator. So it comes down and joins the 4 down here. So it's 1 over 4x. This is x. This is a to the negative 1 power. And a to the negative 1 power gets reciprocated and brought down into the denominator. It joins the 2 down here. Like that. And we got plus 3/4. That'd be your final simplified answer for having divided that trinomial by that monomial. Did anybody get that one correct? Anybody at all out there get that correct?
No, but I see what I did wrong.
All right. Well, this one here, we split this up. We put 16x squared over 12x cubed plus 8x squared over 12x cubed plus 12x over 12x cubed. Now we reduce 16 over 12, reduces down to by 4, down to 4/3. X squared divided by x to the 3rd power is x to the 2 subtract 3 power. 8 over 12 reduces down by 4, down to 2 over 3. X squared divided by x to the 3rd is x to the 2 minus 3 power. 12s reduce out to 1s, and x to the 1st divided by x to the 3rd power is x to the 1 minus 3 power. So what we're left with here is we're left with 4/3 times x to the negative 1 power plus 2/3 times x to the negative 1 power plus x to the negative 2 power. Don't want to leave any negative exponents appearing in any final answers. And so this sits over 1, this sits over 1, this sits over 1. So we reciprocate the x down into the denominator. And this will be 4 over 3 times x. X comes down and joins the 3 down here, plus 2 over 3 times x, plus 1 over x squared. And let's see, if there's anything else we can do here. Well, these are like terms here. These would actually add together to give you 6. 4 plus 2 is 6 over 3x. And believe it or not, we can reduce 6 over 3. This reduces down to 2 over x plus 1 over x squared. Did anybody stay the course and see that one to the end? Get that correct? Anybody get that one correct?
Yeah,
Somebody did. All right, nice job. All right, we'll call that classwork number 1. Dividing by a monomial involves dividing each term of the polynomial by the monomial. All right. All right, there are bigger fish to fry in this section, ladies and gentlemen. It's how to divide by a polynomial now. In order to divide by a polynomial instead of just a monomial, we're going to have to utilize what's called the long polynomial division to take care of that. So let's move on. Long polynomial division. That's what we're going to use. Okay, let's try one over here. Let's go back to basic math first of all. Just revisit something. You remember how to divide a whole number into a whole number? Basic math. 2 divides into 9 how many times?
4.
4 times 2 is 8. Subtract off. Drop down to 3. 2 divides into 13. 6 times. 6 times 2 is 12. Subtract off. You get a remainder of 1. Drop down to 8. Last round of division. 2 divides in 18. 9 times. 9 times 2 is 18. Subtract off and a remainder of 0. This algorithm that we used back in basic math to divide whole numbers is exactly the same algorithm we're going to use to divide a polynomial by a polynomial. So we can try one out here. Suppose I want to take this trinomial, x squared minus 5x plus 6. And I want to divide this trinomial by x minus 3. All right, to do this, ladies and gentlemen, what we're going to do is we're going to use long polynomial division. My divisor will go outside my long division bar, and my dividend is going to be the trinomial. Can we see this here? All right, now you got to make sure that both your divisor and your dividend are in descending order. That's to say that the degree of each term decreases from left to right. We have a 1st degree term. We have a 0 degree term. In the dividend, we have a 2nd degree term, 1st degree term, a 0 degree term. So both polynomials are written in descending order. Another thing is you want to make sure that your divisor or dividend is not missing any powers of x. We have x to the 1st power, we have x to the 0 power. X to the 2nd power, x to the 1st power, and x to the 0 power. We're not missing any powers of x. We're ready to begin our division. First question we ask ourselves to kick this off is how many times does x divide into x squared? I like to call this round 1 of division. Take x squared, place it over x. How does it reduce? How does x squared over x reduce? Reduce it down to what? X. So x becomes the first term in our quotient, our answer above the division bar. We like to keep like terms lined up in columns here, so I'm going to put that x over the 5x here. Now this x is going to get multiplied by my divisor. So I'm going to multiply x by my divisor here. What's x times x? That would be x squared. That goes underneath this x squared. X times a negative 3. It's going to be minus 3x. That goes underneath the 5x. Then what we do is we subtract off this whole polynomial. Now, it's extremely important that you enclose this entire polynomial inside parentheses, and you have the negative sign outside, the minus sign outside. Now, what's x squared minus itself? What happens to the x squareds?
It cancels out.
Yeah, the x squareds add up to 0, they cancel out. What's negative 5x subtract negative 3x? You gotta be careful with all your signs in here. What is a negative 5 subtract a negative 3?
Negative 8x.
Oh, careful. Subtracting a negative is like adding a what? Positive? And what's
Oh.
negative 5 plus 3, right?
Negative 2x.
Yes, you gotta be careful with your signs here. So a negative 5 subtract a negative 3 is a minus 2. So minus 2x comes down. Now we drop down the next term to prepare ourselves for round 2 of division. So we drop down to plus 6. And now we have the second round of division upon us. We ask ourselves, how many times does this x out here divide into negative 2x? To answer that question, this is round 2. We take negative 2x, place it over x, and reduce. What does this reduce down to? The x is dropped.
Negative 1x.
No, this is negative 2x divided by x. What does that reduce down to?
Negative 2.
Just negative 2. Minus 2 becomes the next term in our quotient. We take the negative 2 now and multiply it by our divisor. Negative 2 times x, negative 2x. Negative 2 multiplied by negative 3, plus 6. And now we subtract off the whole polynomial. Make sure you always enclose this polynomial inside parentheses. Now, what's negative 2 minus itself?
Zero.
What happens to the negative 2x's? When you subtract negative 2x from itself, that goes to what, 0?
Yep.
Now, what's 6 subtract 6?
0.
Remainder is 0. Ladies and gentlemen, my quotient is up here. X equals negative 2. So after having divided x squared minus 5x plus 6 by x minus 3, I get x minus 2. That's your answer. This is called long polynomial division. Any questions with what just happened here? Long polynomial division. That makes sense what happened there, ladies and gentlemen?
I don't understand step 1.
Step 1, we ask ourselves, how many times does x divide into x squared? I took x squared off the side of my paper and placed it over x. How does x squared over x reduce? X squared divided by x reduces down to what? X to the 2 minus 1 power or x to the first power. That's why the first term of my quotient is x right here, x. And I took x and multiplied by my divisor and got x squared minus 3x. Then I subtract off this whole polynomial. And then it goes from there. Does that make sense how the first step occurred?
Where are you getting the multiple or the subtraction sign from?
Oh, because when we divide, we always do what? We always what? Subtract when we divide. You see that?
Okay.
We always subtract off the whole polynomial. Okay. Always subtract. That's part of our division algorithm, correct?
Okay. Yep.
The way
Okay.
we pursue things. Yep. That's how we divide. We subtract. You know? That's what we did back in basic math. We're dividing whole numbers. We always subtract it off. You know, we didn't add.
Right, right.
We subtract, you know. All right. Any other questions about that problem there? Maybe we can try another one. Like I said, you can see that there's a lot of steps involved in this, but with practice, I mean, quite a bit of practice, ladies and gentlemen, you are going to get really good at this. You're going to fly through these steps, okay? But it requires practice to get to that level. All righty. Let's try another one. All right, let's try to take, let's see here. Let's do this one here. Let's divide Let's take a squared plus 9a plus 20 divided by a plus 4. So we're going to try to divide this trinomial by this binomial here. All right. All right. What's my divisor? What goes outside the division bar?
A plus 4.
My dividend. Notice both divisor and dividend are written in descending order. First degree term, 0 degree term. Second degree term, first degree term, 0 degree term. We're not missing any powers of x. We don't have to insert what are called placeholders. We're ready to begin our division here. We ask ourselves, how many times is a divided into a squared? Put a squared over a. Now reduce. How does that reduce? How does a squared over just a, right? A squared divided by a reduces down to just a. A becomes the first term in our quotient. We take a, multiply it by our divisor now. What's a times a? A times a is a squared. A times 4. 4a. Subtract off the whole polynomial. Make sure you put this polynomial inside parentheses. If you don't do that, then it's going to look like you're just subtracting off a squared, not the 4a. What is a squared minus itself?
0.
A squareds are gone. What's 9a subtract 4a?
5A.
5a. What do I do next? Bring down to what?
20.
Plus 20. Round 2 of division. How many times does a divide into 5a? Feel free to take the 5a off the side of your paper, place it over a, and reduce this. How does this reduce? A's drop out. 5. So 5 is the next term in our quotient. We're going to take 5 and multiply it by this divisor. All right, 5 times a, 5a. 5 times 4, plus 20. Subtract off the whole polynomial. Again, make sure you enclose this inside parentheses. 5a minus itself is 0. 20 minus itself is 0. Again, we get a 0 remainder. Ladies and gentlemen, this is your answer, a plus 5. So that's your quotient. Questions how we're dividing so far a polynomial by a binomial using long polynomial division. Long polynomial division. You want to try one now?
Yes.
See if you can do this one. All right, we'll call this classwork number, what are we up to? Classwork 2. All right, classwork 2. See if you can divide. See if you can take this a squared plus 9a plus 20. See if you can divide that by a plus 4. Okay? Okay, go ahead and try to do that division there, long polynomial division.
I hate to be the bearer of bad news, but we just solved that problem and right before we did our classwork.
All right, let's see how you did on this. Notice both our divisor and our dividend are in the descending order. We have all the powers of A. A divides into A squared how many times? A squared over A reduces down to what? Just A? A to the second power divided by A reduces down to A to the first power. Put the A over this term. Notice we always keep like terms lined up in columns. Notice that. We're now going to take A and multiply it by our divisor. So A gets multiplied by A plus 4. A times A is A squared A times 4 is 4a. And then we're going to subtract off the polynomial. A squared minus itself is 0. 9a subtract 4a. 9a minus 4a is 5a. And we bring down to 20. Round 2 of division. A divides into 5a. How many times? 5a divided by a is 5. So a divides into 5a 5 times, plus 5 is the next term in your quotient up here. 5 now gets multiplied by the divisor. 5 times a plus 4. 5 times a, 5a. 5 times 4 plus 20. Subtract off the whole polynomial. 5a minus itself goes to 0. 20 subtract itself gives us a remainder of 0. Quotient. There's your quotient, your answer. That's called your quotient. Is a plus 5. Did anybody get a plus 5 for an answer here? Anybody get that for a result?
Yes.
Well, congratulations. You got that. Awesome. Anybody else get a plus 5? We're starting to understand this a little bit, ladies and gentlemen.
Mr. O, you did that with us right before you gave it to us for classwork.
Well, wait a minute. This one had a plus 4 as the divide. You know what? I think I did do that, okay? I apologize. I owe you guys another one, don't I? I do owe you another one, okay? All right, let me show you another one and I'll give you another one. You can call it, you can attach to, call it classwork too, okay? Because that is kind of a repeat, isn't it? All right, let me do this one and I'll give you another one we'll call classwork too. No wonder that seemed kind of easy, huh? All right, let's try to divide this trinomial by 2x minus 1. Right. 2x minus 1 is my divisor. My dividend is the 2x squared plus 5x minus the 3. Here we go. Round 1 of division. 2x divides into 2x squared. How many times? Feel free to take the 2x squared off the side of your paper, place it over the 2x. Now reduce this. You'll have your answer. How does this reduce? How does that reduce down? 2 is reduced out. What's x squared divided by x? Just x. So x becomes the first term in our quotient. Take x, multiply it by your divisor. What's x times 2x? 2x squared. X multiplied by -1. Minus 1x. And then we'll subtract off this whole polynomial here. What happens to the 2x squareds? 2x squared minus 2x squared is 0x squared. 5x subtract a -1x. What's 5x minus a -1x? What's 5 minus a -1? That's really 5 plus 1, which is what, 6? 6x. Drop down to -3. Now we have round 2 of division. Round 2, we ask ourselves, how many times does 2x divide into 6x? Take the 6x, put it over 2x, reduce. You got your answer. How does that reduce? Down to 3. Plus 3 is the next term in our quotient. 3 now gets multiplied by the divisor. 3 times 2x, 6x. 3 multiplied by -1, minus 3. Subtract off the whole polynomial. What's 6x minus itself? 0. What's -3 minus itself? 0. Remainder is 0. What's my quotient? X plus 3. X plus 3, ladies and gentlemen, is your quotient. That's your answer. All right. Now I will give you one to work with, and I promise this one will be different. We'll call this classwork 2. Sorry about that other one. Of course, you have to admit that other one was kind of easy. Take this trinomial, divide it by 2x minus 1. There you go, ladies and gentlemen. See if you can do that. It'll be classwork 2, officially classwork 2 this time. Well, this one's very similar to the last one, but there's a slight difference, obviously. Let's see if we had any success. 2x is your divisor. Your dividend, 4x squared plus 4x minus 3. How many times is 2x divided into 4x squared? Four, 4x squared divided by 2x is what?
2x.
2x is the first term in my quotient. 2x multiplied by 2x gives me 4x squared. 2x multiplied by -1 minus 2x. Subtract off the whole polynomial. Make sure you're enclosing this polynomial inside parentheses. If not, that's going to be an error because you're not just subtracting off 4x squared. You're subtracting off 4x squared and minus 2x. Very important. 4x squared subtract itself goes to 0. What's 4x? Subtract a negative 2x. What's 4 subtract negative 2? 4 minus negative 2.
Is it gonna be 6x?
Yep, is 4 plus 2, so that's 6x. Bring down to negative 3. Round 2 of division, ladies and gentlemen. 2x divides into 6x. How many times? Take the 6x, place it over the 2x, and reduce. How does that reduce?
2, 3.
Just 3. You are correct. Plus 3 is the next term in your quotient. 3 times 2x is 6x. 3 multiplied by negative 1, minus 3. Subtract off the whole polynomial. 6x minus itself is 0. Negative 3 minus itself is 0. Quotient. Anybody get that correct? 2x plus 3.
I did.
Nice job. I think you're starting to get this long polynomial division here, ladies and gentlemen. Long polynomial division. You just got to be careful with your signs. The signs are always an issue with this. So be very careful with all the signs, the subtracting of the negatives and stuff like that. Okay, very careful on that. All right, well, let's see if we can continue to raise the bar a little bit. Let's raise the bar a little bit now, ladies. We've shown you some pretty simple ones so far. Let's see how far we can take this. All right, let's try to do this one now. Let's see if we can, so far we have not gotten any remainder. Do you agree? You think we're always going to get a 0 remainder? We're not always going to get a 0 remainder. Let's try this one. X squared minus 5x plus 8. And we'll try to divide this by x minus 3. X minus 3 is your divisor. Your dividend is x squared minus 5x plus 8. All right, so we're going to try to divide this polynomial by this binomial using long division. So divide using long division. The instructions will say. Notice both divisor and dividend are in descending order. We're not missing any powers of x. X divides into x squared how many times? X times. X first term in your quotient. X gets multiplied by your divisor. X times x. X squared. X multiplied by negative 3. Minus 3x. Subtract off the whole polynomial. What happens to the x squareds? 0. What's negative 5x? What's a negative 5x? Subtract a negative 3x. What's negative 5 minus a negative 3? Isn't that negative 5 plus a positive 3? Which is negative what? Negative 2? Negative 2x. Bring down to plus 8. Round 2 of division. We ask ourselves, how many times does x divide into negative 2x? How many times? Negative 2 times. Minus 2. Next term in your quotient. Take the minus 2, the negative 2, multiplied by your divisor. Negative 2 multiplied by x. Negative 2x. Negative 2 multiplied by negative 3. Plus 6. subtract off the whole polynomial. Notice that negative 2x's drop out to 0. 8 subtract 6 gives you 2. For the first time, ladies and gentlemen, we see that we do not have a 0 remainder. Notice we have nothing else to bring down, so we're done. This is called your remainder. So here's what we do. We bring our remainder up, place it over our divisor, and then add it to the rest of the terms of our quotient. There you go, ladies and gentlemen. This is your entire answer of having divided x squared minus 5x plus 8 by x minus 3. Notice we do have a remainder this time. So your entire quotient has to have the remainder placed over the divisor, added to the rest of the terms. That's what happens when you get a remainder. You bring it up, place it over your divisor, add it to the rest of your terms of your quotient. Okay, so there is one for the first time that has a remainder. Any questions about that problem? All right. Let's see what other trouble we can get into. Let's see. All right, let's try another one here. Now this next one, I'm going to try to divide by not a binomial, but divide by a trinomial. Do you think we're up to the task? I think we're ready for that. So let's try to divide this here. Let's try to take 6x cubed minus 11x squared minus 14x plus 3. And let's try to divide this polynomial by this trinomial, 2x squared minus 5x minus 1. So we're going to try to divide this polynomial by this trinomial using long division. So here's our long polynomial, our long division bar, excuse me. Our divisor is this 2x squared minus 5x minus 1. Our dividend is this 6x cubed minus 11x squared minus 14x plus 3. And now we're going to have to try to divide this trinomial into this polynomial here. All right. Let's see, ladies and gentlemen, if we're going to be able to do that. Now, notice both my divisor and dividend are written in descending order. That's to say the degree of each term decreases from left to right. Second degree term, first degree term, 0 degree term. Third degree term, second degree term, first degree term, 0 degree term. Let's let the division begin. 2x squared divides into 6x cubed. How many times?
Yeah.
How many times was that reduced down to? 3 what? 3
X.
3x. Notice we put the 3x way over here because we like to keep like terms lined up in columns. We always keep like terms lined up in columns. See that? We take the 3x and multiply by our divisor. What's 3x multiplied by 2x squared? Three x times 2x squared, 6x cubed. 2x multiplied, 3x multiplied by negative 5x. Negative 15x squared. 3x multiplied by negative 1. Minus 3x. And then we subtract off this whole polynomial. Got to subtract the whole thing off. What happens to the x cubed term? 6x cubed minus itself. 0. What's a negative 11x squared? Subtract negative 15x squared. What's a negative 11 minus a negative 15? It's negative 11 plus 15, which is what? 4? Negative 11x squared minus a negative 15x squared is 4x squared. What's negative 14x? Subtract negative 3x. What's negative 14 minus a negative 3? That's negative 14 plus 3, which gives you negative 11. Bring down the 3. We have another round of division to do now. We ask ourselves, how many times is 2x squared divided into 4x squared? What do you think?
2x.
Just 2? 2 times? 4x squared divided by 2x squared. 4x squared divided by 2x squared is just 2. 2 gets multiplied by our divisor. What's 2 times 2x squared? 4x squared. 2 multiplied by negative 5x, negative 10x. 2 multiplied by negative 1, minus 2. Subtract off the whole polynomial. What happens to the 4x squareds? What's 4x squared minus itself? 0. What's a negative 11x? Subtract a negative 10x. What's a negative 11 minus a negative 10? That's a negative 11 plus 10, which is what? Negative 1. 3 minus negative 2. 3 plus 2. 5. 3 minus a negative 2 is plus 5. Now we have nothing else to bring down, so we're done. So therefore, this is our remainder here. And so what we do is we bring a remainder up into the quotient here, place a remainder over the divisor. We add it to the rest of the quotient. This would be your entire answer here. All right. So when you got a remainder, you bring it up, place it over your divisor, and then add it to the rest of your quotient. This is your entire answer for that problem. Any questions on we tackled that one? Dividing by a trinomial, long polynomial division. So when you have a remainder, you bring it up, place it over your divisor, and then add it to the rest of the terms of your quotient, okay? All righty. Now, let's look at this next one here. We'll try to take x cubed plus 1 and divide it by x plus 1. Using long division. So therefore, my x plus 1 is my divisor. And my dividend is x cubed plus 1. Ladies and gentlemen, we have an issue here though, big issue. Notice my divisor despite being written in standard form, is missing a power of 2 term, and it's missing an x squared term and an x to the first power term. Because we're missing x squared and x to the first power in between x cubed and our 0 degree term here, we have to insert what are called placeholders in our dividend. So we're going to have to insert a placeholder in the form of 0x squared. We're also going to have to insert another placeholder in the form of 0x. So that now our dividend has all the powers of x: 3rd degree term, 2nd degree term, 1st degree term, 0 degree term. Must put these placeholders in. They're called placeholders. If you don't put these placeholders in, your terms are not going to line up properly and your division is going to fail. Okay, must put those placeholders in. Called placeholders. They don't change the value of your dividend. Your dividend is still x cubed plus 1. All they do is they're going to hold a very important place. Okay. So let's begin our division. X divides an x cubed how many times? X squared times. Take x squared multiplied by your divisor. X squared times x, x cubed. X squared times 1 plus 1x squared. Subtract off the whole polynomial. What happens to the x cubed terms? They drop out. Let's 0x squared subtract 1x squared. Negative 1x squared. Drop down the next term of 0x. We have another division to go through. We ask ourselves, how many times is x divided in negative 1x squared? How many times, ladies and gentlemen? What does this reduce down to?
X.
Negative 1x minus x, next term in your quotient. Take negative x multiplied by your divisor. Negative x times x, negative 1x squared or negative x squared. Negative 1 times 1, minus 1x or minus x. Subtract off the whole polynomial. What happens to the x squared terms? What's negative 1x squared minus itself? 0. What's 0x subtract the negative 1x? 0x minus negative 1x. What does that give me?
One.
1x. Bring down to plus 1. We have one more round of division to go through. We ask ourselves, x divides into x how many times?
1.
1 plus 1. Multiply 1 by the divisor, and 1 times x plus 1 is x plus 1. Subtract off the whole polynomial. X minus x is 0, 1 minus 1 is 0, 0 remainder, ladies and gentlemen, that's your quotient. For the first time, we've seen where we had to add some placeholders in our dividend because we were missing powers of x between the 3rd degree term and the 0 degree term. Placeholders, gotta have them. If you don't put those in there, your division's not going to work. Very important. Any questions about that problem? Placeholders. All right, we all good on that one? Let's try this one. A squared plus 4a plus 3. Try to divide this polynomial by a squared minus 5. Long division. Using long division. My divisor is a squared minus 5, but ladies and gentlemen, do you spot something? What are we missing in our divisor? We're missing something in here. What are we missing?
A number with an A.
Yeah, we're missing an a to the first power term in between our second degree term and 0 degree term. We must insert a placeholder in our divisor. The divisor must be a squared plus 0a minus 5. Got to have this placeholder in here. Must have the placeholder, else things are not going to work out correctly. Notice my dividend has all the powers of a. Second degree term, first degree term, 0 degree term. We're good with our dividend. Here we go. Let's begin our division. How many times is a squared divide into a squared? How many times a squared divide into itself?
Once.
Once. Where do I put the 1? Above this term, or this term? Where do I put the 1?
Above the 4.
No, remember, like terms have to be lined up. This is just 1, right? Above the 3, yep, way over here above the 3. We want to keep like terms lined up. Don't put the 1 here because 1 doesn't have an a attached to it. A squared divides into itself only 1 time. 1 times our divisor, 1 times a squared is a squared. 1 multiplied by 0a is 0a. 1 times negative 5 is negative 5. Subtract off the whole polynomial. A squared minus itself is 0. 4a minus 0a is 4a. 3 subtract a negative 5 is really 3 plus 5, which is plus 8. Nothing else to bring down. This is your remainder. So we say 1 plus, we put 4a plus 8 over our divisor. And when you place it over your divisor in the end, you do not have to include the placeholder. So this is just over a squared minus 5. Ladies and gentlemen, that's your quotient of this problem, and we're done. There may be times when you have to add placeholders to your divisor and or your dividend. Be on guard for that. Any other questions about that problem? Okay. Try this one. 6a to the 4th minus 2a squared plus 9. And we're going to divide this, or try to divide it, by 3a squared plus 2. Using long division. My divisor is 3a squared plus 2, but what's missing in my divisor? What am I missing?
0a.
Yeah, I'm missing an a to the first power term in here. Must insert placeholder in the form of 0a. My dividend, I have a 4th degree term, but then I go down to a 2nd degree term. I'm missing a 3rd degree term of a in between these two. Must insert placeholder in the form of 0a cubed. I'm missing a 1st degree term in a between my 2nd degree term and my 0 degree term. Must insert another placeholder in the form of 0a. There you go. Must add all these placeholders in order for this to work. Very important, placeholders. All right, let's begin our division. We ask ourselves, how many times is 3a squared divided into 6a to the 4th? How does that reduce?
2a to the 2nd.
2a squared. Where do I put the 2a squared? Above what term of the dividend?
Above the 2a square.
Above the minus 2a squared. Yes, keep like terms lined up in columns. We now take the 2a squared and multiply it by our divisor. What is 2a squared multiplied by the 3a squared over here? 6a to the 4th. What is 2a squared multiplied by 0a plus 0a cubed? What is 2a squared multiplied by 2? 4a squared. Subtract off the whole polynomial. 6a to the fourth minus itself, 0. 0a cubed minus 0a cubed, 0. Negative 2a squared, subtract 4a squared, negative 6a squared. Drop down to 0a. And ladies and gentlemen, since we're dividing by a trinomial, we drop down the next two terms, the 0a and the 9. Drop all that down. Because we're dividing by a trinomial, we drop the next two terms down. All right, here we go. 3a squared divides into negative 6a squared. How many times? How many?
Negative 2.
Just negative 2 times. Minus 2. Where do I put the minus 2? Above this term or the a or the 9? The minus 2. Goes
Above the 9.
Yeah, above the 9. Minus 2. What is minus 2 times 3a squared? Minus 6a squared. What is minus 2 times 0a? Plus 0a. What is negative 2 multiplied by positive 2? Minus 4. Subtract off the whole polynomial. Negative 6a squared minus itself is 0. 0a minus itself is 0. 9 minus a negative 4 is 9 plus 4 or 13. Hence our remainder, we bring it up, place it over the divisor, which we just say is 3a squared plus 2. And then we add it to the rest of the terms of the quotient. There's your answer. This is your complete answer, okay? Ready to try one, ladies and gentlemen? All right, I'm going to give you one. This will be classwork number 3. Classwork 3. All right, classwork number 3. You can try that one. And then try this one. All right, there's 2 problems. All right, classwork 3. See if you can do those divisions. Okay, let's see if we got the first one. Anybody get the answer for the first one here? Got to put some placeholders in for the dividend here. X cubed plus 0x squared plus 0x minus 8. Hopefully you put the placeholders in. X divides in x cubed, x squared times x is x cubed. X cubed, x squared times -2 is -2x squared. Subtract. X cubed minus itself is 0. 0x squared minus a -2x squared is 2x squared. Drop down to 0x. X divides into 2x squared, 2x times. 2x times x, 2x squared. 2x times -2, -4x. Subtract off the whole polynomial. 2x squared minus itself is 0. 0x subtract the -4x is 0x plus 4x. Bring down to -8. X divides into 4x plus 4 times. 4 times x is 4x. 4 multiplied by -2 is -8. Subtract off the whole polynomial. 4x minus itself is 0. -8 subtract itself is 0. 0 remainder. Anybody get this for an answer?
Yes, I did.
All right, congratulations. That's that one there. So that's the answer to classwork 3, number 1. Well, for classwork 3, number 2, we have to divide a squared plus 1, but a squared plus 1 is missing a power of a, so we must add a placeholder for a divisor. And that's going to go into a squared plus 3a plus 2. Now a squared divides into itself one time. 1 times a squared is a squared. 1 times 0a is 0a. 1 times 1 is 1. We minus off the whole polynomial. A squared minus itself is 0. 3a minus 0a is 3a. 2 minus 1 is 1. Nothing else to bring down. This is your remainder. So we say plus, and we put the 3a plus 1 over our divisor, which is a squared plus 1. Did anybody get this for an answer?
I got that.
And there you go, ladies and gentlemen. So in this section here, what we discovered is we showed ourselves how to divide a polynomial by a monomial. And we also showed ourselves how to divide a polynomial by a polynomial in general using long polynomial division. All right, so I think that's good enough for this section. I think I've showed you enough of these, and we went over enough of these in our classwork to have success in our homework. All right, so ladies and gentlemen, I will release chapter 5 quiz to you, and we'll make it due by midnight Saturday night, November 20th. Okay. If there are no other questions, you have a great weekend. Stay warm, stay safe. And hopefully I'll see you next week, as we have a kind of an abbreviated week next week because we have our Thanksgiving break on Thursday, which is probably a break that all of us need. I don't know about you, but I would like to have one day off. It would be nice. All right. Take care. Have a good weekend.
Mr. O, can I see classwork number 2, please?
Yeah, what was that? Classwork number 2. Hold on a second here. All right, number 2. Okay. Wait a minute. Number 2. Number 2 was the one whereby, here we go. Okay, sorry about that. There's number 2. Okay.
Just those 2 problems?
Well, I initially gave you this one up here, which was a repeat, so it was really, it was this one here. This was the official classwork too, okay?
Okay, and then I have one question. So I
Mhm.
missed class on Monday and I emailed you. How do I go about classwork?
Oh,
Or do I just, it just
well,
kind
no,
of,
wait, let's see, well, I am gonna drop one more with classwork, so that'll probably be your drop there, okay?
okay, that'll work.
And I do have the video on there for Monday's session, so please take time to watch that, okay?
Gotcha. Okay,
All right,
thank you.
let's see 'em.
Bye-bye.
Are you gonna give us classwork? Homework.
Oh, yes, I will update the homework, yes. Mhm.
Thank you.